Well, first of all, I just want to say how grateful I am to be here. Super excited to talk to you all. This is my first time in India, my first time in Bangalore. Having a really great time. You all have been so welcoming. I love the food. The traffic is interesting, quite fascinating. So I'm here to talk to you today about the future of serverless. And whether you're new to serverless or an expert in serverless, I hope that you can learn something today, and I hope to learn something from you as well. So I think that, the view that we have of serverless and the view that we hear from customers really is summed up very, very well by this talk, this presentation that our CTO Werner Vogels gave in 2017 at reInvent. And the idea is that all the code you ever write is business logic. And why does that sum up serverless so well? Because it's allowing you to focus on what matters most, the unique thing that you are bringing to your app, to your customers. And you don't want to spend time on anything but that. And that's what serverless is all about. And if there's one thing that I want you to walk away from today from this presentation, is that that's also the future of serverless. That mission that we have is not going to change. The details of how we do it, because the world is changing around us, might change, but this is the mission. And this is actually the future of serverless. So that's really the one thing that I want you to remember if you remember anything from this talk today. I find it super valuable to hear this kind of thing directly from customers. And this is a fantastic quote from one of our serverless customers, Liberty Mutual, where they saw exactly these kind of benefits, that they were able to respond to the changing market around them and to the changing customer needs more quickly because they adopted serverless. And one of the things that I want to point out here is that it's not just that they were able to move faster with serverless, it's that they were able to do things that they couldn't even do before. Like they were able to do AI integrations that before they had adopted serverless, they just didn't have the time to do because they were spending so much time managing infrastructure, managing capacity, managing scaling. And so serverless is a lot more than just speed. It's also opening up these new worlds that you didn't even have access to before. So this is kind of a visual representation of how I think about serverless. Like, what is serverless actually? You can think of this vertical stack starting at the very bottom with physical infrastructure. That's the actual racks and the data centers. And then there's compute abstractions like VMs that are built on top of that physical infrastructure. And you move higher and higher up the stack, and you have these higher level abstractions. And serverless fits today at the top of that stack. When you create a serverless function, it's code, and it's code that you want to run. And you're not thinking about where that code runs. You're not thinking about what kind of server it runs on or what the network configuration is. You're just thinking about the code. And that's what we want you to be thinking about. We want you to be thinking about that code and what is it supposed to do. And don't worry about anything below that in the stack. And you can think about this stack as a continuing evolution where we are focusing our innovation efforts on filling in management in the lower levels of the stack and creating ever higher levels of abstraction for you. And you can think about AI as actually fitting into this stack as well. AI in some ways is another layer even higher in the stack, where instead of business logic now, you have just human intent, like what do you want to have happen? That's an even higher level of abstraction. And so this is a really useful mental model to have when you think about serverless and how it fits into your entire estate and what the evolution of technology is over time. And so what are the benefits that people realize when they adopt serverless? The obvious one in the name is that there's no infrastructure to manage. You're not managing servers, you're not managing capacity, you're not doing scaling. You don't have to think about if I'm going to build an application and it's going to scale up and run on my big sale that I'm about to run. I don't have to think about how many servers I need in order to run that application. Sorry, the monitor just went blank up here, so I'm going to use this laptop. Paying for value. What does that mean, paying for value? Paying for value means you pay when your application is doing work, and you don't pay when it's not doing work. You don't have to pay for idle infrastructure. You don't pay for a bunch of servers that you're not actually using. You pay when you get value. You don't pay when you don't. And this allows you to start small, create a simple prototype, start small, and it's very cheap. And you don't pay until you start to scale that application up. The last point is a really interesting one, and it's kind of subtle, which is that when you use serverless, when you are adopting those higher levels in the stack, you are taking advantage of all of the knowledge and experience that AWS has in building the lower levels of the stack. So when it comes to things like availability, resilience, security, you're getting the best practices of AWS and Amazon in how to run at absolutely massive scale, reliably and securely, and you don't have to do anything to get those benefits other than use serverless. So we've been investing in serverless ever since 2014 when we launched Lambda. It was really we didn't create the word serverless, but we kind of invented this category of serverless. And it's hard to describe just how new serverless was back at that time. The idea that you could just give us your code and it would run when it needed to. You know, in 2014, the cloud was still relatively new. So the idea that you were going to run an application in the cloud instead of on a physical server that you could see and touch, even that was kind of a big deal. And so then to go a step further and say, there's not even a server, was a really big step, a really big leap. And we've been investing continuously since then in serverless to add more and more managed capabilities around things like storage. So you could access storage from your serverless functions, networking capabilities, compute performance, event integrations. The list goes on and on. I'm not going to go through all of them. This slide stops at 2024. We actually have some really fantastic things that we've launched in 2025 as well. Really popular IDE integration for Lambda that allows you to do remote debugging of a function in your IDE. Some other really cool things that we've launched. And we have a lot of things coming in the future that I'm going to hint at. I can't tell you everything about them. You'll have to wait for reInvent to see those things, but I'll kind of hint at some of the things that are coming. But the point here is that, that stack that I showed you, starting at the bottom and moving up, we're continually investing in all layers of that stack to improve the experience that you get with the higher level of serverless abstractions. Okay. I like Werner, so I like to steal Werner's slides. He's more of a rock star than I am. And so one of the most popular ways for people to use serverless is what's called an event-driven architecture. You may have heard of an event-driven architecture, you may have not. I'm going to spend a little bit of time talking about what an event-driven architecture is. So first of all, let's talk about an event. What is an event? It's a change in something or an update to something. And we have a bunch of examples from different industries listed here. And I believe that actually the vast majority of software is event-driven. You may not realize it. The developer of that software may not think of it as event-driven, but it's actually event-driven. That event might be a user clicking on a button, right? It might be a webcam, like watching something and detecting motion. And so virtually all software is event-driven. And it makes sense if you think about it, right? Like if nothing happens, what is your software doing, right? Your software only does something if something happens. Your business, your workload, your app that you're offering to your users, it provides value to your users by doing something when something happens. That sounds like a really silly thing to say, but that's actually the nature of software. It's all event-driven. And serverless was built for events. Back in 2014, when we launched it, It was originally launched to be kind of an S3 processor. So you would like upload something to S3 and then you could write code that could automatically process things that were uploaded to S3. So Lambda from day one was actually event-driven. And this is the most popular type of application to run on serverless, and there's a ton of benefits for that. So there's technical benefits to an event-driven architecture, and there's also like sort of people and organizational benefits to an event-driven architecture. The technical benefits are things like decoupling systems so that they can scale independently, because you can have an event producer and an event consumer, and they're not directly coupled. They have something like an event broker, like EventBridge, sitting in the middle, and the team that is publishing the events doesn't have to worry about how the team that is processing the events handles those. They can write their code and run it independently. Now, I kind of hinted at the organizational benefit. The teams are also decoupled. And this is really, really important when it comes to velocity of software engineering. If you have 100 people in your organization, and every time you want to make a change, all 100 people have to know about it and have to participate in that code review, it gets really, really slow. But if you can take those 100 people and break it up into 10 teams of 10, and each team of 10 can ship as fast as they want to independently of those other teams, you dramatically accelerated the speed of software development in your organization. And an event-driven architecture enables you to do that. So event-driven architecture is not just a technical thing, it's also an organizational thing. And this is one of the most popular architectures that people use with serverless today. And so serverless has really found very broad customer adoption in the 11 years since we launched Lambda. Today, there are over 1 million active customers using Lambda every month. This second statistic is the one that really blows my mind. It's actually very difficult to comprehend the scale of this. There are over 10 trillion function invocations every month on Lambda, 10 trillion. I actually have a PhD in math, and I should be able to do the math to calculate how many of that is per second, but I don't remember the number off the top of my head of what it is per second, but it's like on the order of tens of thousands per second. So at the time that I've been standing here, there's been an enormous number of Lambda function invocations that have happened. And so serverless has become extremely popular, and event-driven architectures have become extremely popular. So where do we go from here? You can look at serverless as kind of the part of this evolution that the cloud has been on, even since before the cloud, the introduction of VMs, and then the cloud, and containers, and serverless. And so what's next? Where are we going with this? Is there going to be something that replaces serverless? Is there going to be an even higher level abstraction? That's what I want to spend the rest of my time with you talking about today. So, I know you all have heard of agents. We at AWS think agents are going to be very, very big. There's going to be millions of agents out there running, doing many, many things that today are done with traditional software, as well as things that traditional software simply can't do. We think that we're going to see agents running in consumer, in enterprise, and industrial settings. They're going to be doing very complex workflows, very simple workflows. They're going to be doing customer-facing interactions. They're going to be doing back-end operations. To sum it up, agents are going to change how we work and even how we live. And so what are the things that distinguish an agent from traditional software? Agents are goal-oriented. They actually decide what to do to achieve a goal. They use information, context, in order to achieve that goal. And they can decide what context is important and what context isn't important. They use tools, right? So an agent can interact with traditional software, including serverless functions, in the form of tools to accomplish its mission. They can actually remember things. They remember what happened last time. They remember what you said, and they can change how they proceed based on that information. And then they make decisions and execute actions based on those goals. So it might be tempting when you look at that slide that I had with the question mark on it, the arrow going up and to the right and the question mark, to think that, agentic is the next thing, and that's what's going to replace serverless. And when you run agents, you don't need serverless anymore. And that I can understand why somebody might think that is kind of a binary thing and that the world's going to transition to agents. And I think the world is going to transition to agents. I am a very big believer in the agentic future. I think the potential is enormous. I don't think any of us truly understands just how big the potential is for agentic AI. But my view, and the view of serverless, is that as we all transition to agentic, as we build more and more workloads that are agents instead of traditional software, you're actually going to need more serverless. Because the things that you get with serverless, no managing of infrastructure, the automatic scaling, the pay for value, the well-architected fundamentals of security and availability and scale, those are things that you need even more of when you're running agents. And so it's not an or with agents, it's an and. So let's dive into that a little bit more about what that future with agentic AI looks like with serverless. There actually are kind of two emerging patterns for agents. One of them is the one that we just talked about, which I think is what most people think of when they think of an AI agent, which is you have an LLM, you have a prompt that defines a goal, you hook that LLM up in a kind of iterative loop where it can understand context and it can use tools and can plan and perform actions. And that agent is fundamentally non-deterministic. What does that mean, non-deterministic? What that means is that you don't necessarily know in advance exactly what it's going to do. The agent is not following a pre-planned series of steps to accomplish its goal, which might sound a little scary. Why? What? I don't know what it's going to do. That's actually the point of agents, is that you don't have to spend time defining what those steps are. You just give the goal, and you make sure that the goal is aligned with your business objectives, with your product objectives, and then the agent figures out how to make it happen. Now, sometimes, and I would argue many times, you don't need an LLM to figure out what to do because you actually already know. You know exactly what steps need to happen in order to accomplish something. And for that type of workload, using a multi-billion parameter LLM is probably overkill. That doesn't mean there's no use for an LLM, but there are other workloads that we call agentic workflows where you use something like step functions to define a workflow, and that workflow has a nice, well-defined series of steps. And you, as the developer, are defining the business logic in that workflow. But within that workflow, you may use an LLM. Like, for example, you might have a document processing workflow where a user uploads a document and you need to extract some text, you need to store it somewhere. There's some steps that you do that are kind of boilerplate standard things that you do. And then you get to a point where you say, now I want to summarize the text that's in this document. And your workflow goes and calls an LLM and gets the result back from that LLM. And so you can use LLMs with a workflow, but the LLM isn't driving the bus. The LLM is not making the decisions. It's just providing that unstructured data processing. And so these are kind of the two different patterns that we see with agentic, is full-on agentic AI and agentic workflows. And these are both becoming more and more popular, actually. It's not just all about the agentic AI. And so when you look at both of these use cases, they are both event-driven. When do you need to run your agent? When should you start up a new agent session? Well, when something happens. And what is something happening? It's an event, right? A user connects and has a question. That's the event. So you start up an agent. Also, within that agent, as it's running, it's interacting with a user, and it makes a decision to use a tool. That's an event, right? The decision of an agent to use a tool is an event. That's a key point, is that an agent can be both a producer and a consumer of events. It can consume events to start up, and it can also produce them, which then trigger other downstream systems to take action. And workflows are similar. They're also event-driven. And for both of these, what you need is a system where you don't have to think about infrastructure, where scaling is automatic. And that scaling automatic piece is especially important when you think about an agent that is running, that's going to use tools, and you don't know in advance what tools it's going to use or how many or how often. In that world, where your agents are non-deterministic, are using tools at a frequency and a scale that can't be determined in advance, do you want to sit around and do capacity planning and figure out how many servers are we going to need for our agents' tools to run? It's going to be impossible to answer that question, right? With serverless functions, if you define a serverless function as a tool that an agent can use, there's no planning required. You hook the tool up to the agent using something like MCP, which you can do today. You can create an MCP server, a model context protocol server, that exposes a Lambda function to an agent as a tool. You provide the context to the agent, and if the agent decides to invoke that function, it will invoke it, and the function will run, and you'll pay for the function if it runs. If the agent doesn't use the tool, there's nothing to run. You don't pay for the function. You never had to think about scaling in any of that, right? So this dynamic nature of agents is what makes them ideally suited for serverless. So it's already the case today that serverless is built for agentic AI. But what I want to help you think about is, number one, to help you understand what are we doing to make that process even better? How are we helping you to build for the future with serverless and agentic AI? And what are the things that you should think about as you build applications, as you build workloads, whether or not they're agentic? What are the things that you should be thinking about to build for the future? And so some of the things that we're investing in to improve this experience of agentic AI with serverless is around payloads and limits. So when you piece together a multi-component application with Lambda functions and SQS queues and agents in the mix, one of the things that you need is consistency of payloads across those. Like the agent might take in an image and might produce a bunch of text streamed out as a result that goes into a Lambda function, that goes into a queue. And so we're working on harmonizing all of the payloads and throttles across all of those services so that you have a consistent experience. It sounds like a silly thing, but this can be really powerful when you remove those blockers. Workflows. We have some incredibly exciting things planned for workflows with step functions and with Lambda to create entirely new experiences where you will be able to write workflows in a completely new way that are really very well suited for agents. The fundamentals of developer experience, and this is broadly applicable not just to agentic AI, but any serverless application. Things like local development experience. You know, when I'm a developer and I want to be in that inner loop moving as fast as possible, I like to write things on my laptop. I am a developer too. This is why I love talking to developers, because I'm a developer too. And I love writing on my laptop and iterating as quickly as I can. Performance. Things like cold starts, compute performance, throughput, latency. Fundamental investments that we're making to ensure that serverless has the right performance to meet the needs of EDAs and agentic workloads in the future as you all scale up and we go from 10 trillion to 100 trillion to even more invocations per month. And what are the things that you should be thinking about as you build for the future? And I strongly encourage you to think about the outcomes that you're trying to achieve for your business or your application or your customers. Don't think about the inputs, right? The inputs being, you know, which model should we use? Which language which should we use to write our functions in? Those are kind of inputs. The output is, what events do you care about? And what are you trying to achieve for those events? When somebody clicks buy on your retail site, what are you trying to achieve for that event? Well, one, you'd kind of like to make sure that they're actually able to buy the thing, right? That they complete that workflow. That's a business level metric that you should focus on. And when you look at the events that are important for your business, where do you need an agent to process those? Where could an agent bring value that traditional software couldn't? Or where can you use a workflow with an LLM, an agentic workflow? Right? Agents aren't for everything. There may be some things where you can just write a function to process that event. But we think that agents are going to change the types of applications that you can build. And there may be things that you can do with events with an agent that you couldn't do before. And what tools and systems does your agent or your workflow need to interact with? Can you leverage existing functionality that you already have and hook that up to an agent to create a new experience for your customers to achieve things that you couldn't achieve before? So as you're on this journey, this is kind of a framework that we've developed at AWS to think about how do you actually achieve value? How do you get started and achieve value with serverless and agentic AI? And I think the main message that I want to share with you here is start now. Don't wait. Don't spend a bunch of time planning and writing and not getting started. Because what you'll find is some of this you can only learn by doing. All right? What can an agent do for you, and what can serverless do with that agent? I can't tell you all of that because only you know when you get started with your application and your business. So you want to get to that point here of proof of value as quickly as possible. And you may need to iterate multiple times to get to that point. So don't wait. Start now. Like literally right now, I want to see you pulling out your laptops and typing code. Okay, so I'm really excited that I got a chance to talk to you today, and I'm really excited to see what you're all going to go build with serverless, and let's go build the future together. I'd love to hear from you after the session. I don't know that we're going to have time for questions right now. I'm going to be around. Thank you so much. Really excited for the rest of the day here.